So that's the idea. It's very interesting. And we are also interested in comparing, this result with structural trapping only and with structural plus hysteresis trapping. And I'm not sure whether our model is, you know, infinite or not, but maybe it's not infinite in infinite aquifer. So I will take from case 2A. Let's rename it case 2A. Okay. And I will take the case from that. Now we have structural trapping only, structural plus hysteresis only, and structural plus hysteresis plus solubility trapping. So to compare the three, I will first take this structural and let's put it on the bottom, on the dashboard, I mean. Okay. And now the 2A, structural plus hysteresis only, drop it there. And lastly, 3A, structural plus hysteresis plus solubility. All right. And let's check the display. 2D view. This also 2D view. And lastly, 2D view. Okay, make some adjustment in if you want. Can we do that? Okay. And there. Okay. Yeah, sometimes it's a little bit difficult, but yeah. Okay, I hope you get that. Squeeze it and let's expand it a little bit. Okay, so now let's change everything in gas saturation first. Gas saturation. Okay, so now let's just play. You see on the left, we have structural trapping only. Okay, that's why, because now the trapping is the weakest, it can propagate far away from the well. Okay, very few CO2 being trapped at this section. Okay, almost all CO2 is trapped by the structural boundary at the top. And now we have also on the right, oh, I cannot do that. And maybe I can, oh, I want to touch this and move to the right. And let's expand it. Okay, beautiful. Okay, make it smaller. Okay. And on the at the middle, we have structural plus hysteresis only without solubility. And as you can see, now we have more yellow area because we have more trapping by the hysteresis effect. And the propagation of CO2 at the top becomes, shorter because now we have stronger trapping that will restrict the movement or the propagation or the migration of CO2. Okay, but on the right, we have now more contribution from solubility trapping and the propagation of the CO2 even shorter, but we have more yellow area because now more and more CO2 is trapped. Okay, CO2 is trapped by not only hysteresis but also by solubility trapping. And we can also check as usual this. They are different, completely different, right? Especially structural trapping only. Let's show it again. Okay. All right. Okay. Beautiful. Very, very, very different. Okay. Now the hysteresis dynamic trap gas saturation is 0.05 here, and but we have greater saturation there. Greater saturation there. Okay. And of course, we can also check water mole fraction. Only the solubility trapping has it. Okay, because we only have the trapping of CO2 by dissolving it into the water only in solubility trapping case. Okay. Structural trapping case and structural plus hysteresis trapping case do not dissolve the water. And of course, we can also change it to mass density, water mass density, and the same result with water CO2 mole fraction will occur. Okay. And you see here the mass density is 1006. Here also 1006. But now we have greater than 1018 because of now CO2 being dissolved into the water, making the brine heavier and more dense. Okay, so you get that. It's very interesting. Now we can also check the time series plot as usual.